I'm giving you a distribution. That means that we're dealing with what? Population. If I'm giving you a sample, so a bunch of then of course that's we're dealing with sample statistics. And when we're dealing with population statistics, that's when we can talk about expected values. Make sure that you know how to calculate expected values, variances, and standard deviations from a distribution, especially a bivariate distribution. So we can have X, Y, like our accounting problem, student accounting and non-accounting, something like that. Make sure you know what conditional probability is. And of course, like I said, you can't pass this course if you don't know how to take expected values. I mean, this is just critical. Make sure that you know how to calculate, given that I give you a distribution, that you can calculate the covariance and the correlation of the random variables. Make sure you understand what a point estimator is, like X bar. X bar was a point estimator, and B naught and B1, they were point estimators. But even more important than that, make sure you understand what a sampling distribution is. What is a sampling distribution? Huh? What is a sampling distribution all about? It's in the case of X bar. Well, X bar is what? It's a point estimate, right? And sampling distributions are about the distributions of the point estimator, X bar being the classic example. So if I give you a sampling distribution, you need to know how to pick that apart. Make sure you know how to compute the confidence intervals using both the T and the Z distribution. And also make sure you know how to calculate probabilities given given a distribution. Again, expected values, they are important. Remember the properties of point estimators that we like: linearity, unbiasedness, efficiency, and consistency. The authors are very keen on consistency. That's nice, but I'm more interested in unbiasedness and efficiency. Those two are very important. Make sure that you understand what they mean. And then, of course, the assumptions of the model. Now, you get one sheet of paper you could bring to the exam, and you could write anything you want there. Don't bring a scroll, or don't bring a blanket, or just one 8 by 11. That should be enough, right? You could write it as small as you want. So you can list the assumptions of the model, part of your. However, you need to understand what they mean and how they relate to or not to our least square estimates. Remember, the assumptions of the model are just that, assumptions. But there were some results of least squares that are very related to the assumptions, but they're not the same thing. For example, the expected value of the errors, right, is equal to 0. That's an assumption. The sum of the squared residuals is minimized. Is that an assumption? No, that's a result of least squares. This is what we mean by least squares, right? So whenever we're dealing with the expected values, it's usually we're talking about assumptions. We're assuming that our variables are behaving a certain way or should behave a certain way. And whenever we're using the summation sign, it's we're dealing with sample statistics. So make sure that you know